Have you ever looked at an exam question and wondered how it connects to the real world? Well, in this explainer, we're going to crack open a real GCSE computer science question on embedded systems. I'm going to show you exactly how to lock in those top marks. All right, let's jump right in. Right, so here's the challenge. It's from the OCR J27701 paper, and it's all about a car's follow me system. This is a perfect example of an embedded system, a computer built for a specific task. We're going to break this down piece by piece and figure out how to grab every single one of those marks. First up, part 1. This is all about ROM, which stands for read-only memory. Now, you can think of ROM as the absolute bedrock of any computer system, whether it's in a car or your games console. So let's get a really clear handle on what it is. Okay, the most crucial thing to get about ROM is that it holds the essential permanent instructions a system needs just to wake up and do its job. It's the very first thing the system reads when you power it on. It's kind of like the system's DNA. It's the permanent code that tells it what it is. And because it's permanent, we call it non-volatile. The info stays there even with the power off. And check this out. These are literally the answers the mark scheme is looking for. This is what gets you to points. To snag those 2 marks, you just need to pick 2 from this list. So you could say startup instructions or BIOS, and then for your second point, you could say firmware or even the specific program for the follow me system. Using these exact keywords is what examiners love to see. All right, let's move on to part 2, RAM. Now, if ROM is the system's permanent, unchangeable instruction manual, then RAM is its busy, active workspace. It's where all the action is happening right now. Basically, RAM is the system's short-term memory. It's holding all the information and the programs that are currently running. It's super fast, which is great, but here's the catch. The moment you cut the power, it forgets everything. Poof, gone. That's why we call it volatile. So for our car, the RAM is constantly juggling live, changing data. To get the full 3 marks here, all you have to do is list any 3 examples of this kind of temporary data. And look how specific they are. Current distance from car in front, current speed, a reading from a sensor. It's all about what's happening in that exact moment. Okay, let's tackle the final part of the question. Now, this is a 2-mark explain question about virtual memory. And these are a bit different, right? They're designed to test not just what you know, but if you can connect the dots and apply that knowledge. So, what even is virtual memory? Well, you can think of it as a backup plan for your RAM. When your computer's super fast RAM gets completely full, maybe you have too many tabs open, it cleverly uses a chunk of your slower hard drive as an overflow area. It's a neat trick, but it's much, much slower than using real RAM. So you have to ask yourself, would a dedicated little system like this ever need that? And the answer is a big, fat no. I mean, think about it. This system in the car is a total specialist. It's been designed to do one job and one job only. It's not trying to juggle a web browser, a game, and a video editor all at the same time. So, to get those 2 marks, you need to build a simple, logical argument. Step 1, you make your point. The system has limited functions, right? It only runs a couple of programs and doesn't need to store much data at once. Step 2, you explain the consequence. Because of that, it's never going to run out of RAM. Therefore, virtual memory just isn't necessary. See that? Point, then consequence. That's the magic formula. Okay, let's pull all of this together into a solid strategy you can use for any question like this one. This is how you turn what you know into actual marks on the paper. Look, it really boils down to a few things. First, you've absolutely got to know your definitions for things like ROM, RAM, and virtual memory. But just knowing them isn't enough. You have to apply that knowledge to the scenario, in this case, the car. And don't forget to use those killer keywords like volatile and non-volatile. Finally, for those explain questions, remember the structure. Make a point, then explain why it matters. That is the difference between knowing the content and absolutely acing the exam. So now that you've got this under your belt, you'll start noticing these incredible embedded systems literally everywhere, from your microwave to the traffic lights you pass on the way home. They are the secret brains running our modern world. So keep your eyes peeled for them.